So in this case, we are going to have a continuation as we are working with our revisions. So this is Limpopo provincial government that we are going to be working with, which is for our grade 9 mathematics as we are preparing for the June examinations. That is the one that was written in June 2024. So this is a request actually that we are going to be working with as I have worked some of the other questions. Remember, I said if you have got a certain province that you want me to work on, you can have that one as a request so that we can work on those questions together, try to figure out how you're supposed to attempt those typical questions. So if you have done other provinces, it's fine. You can add the information to what you had. So this one, guys, make sure that you go through the instructions and information. So in this part that we are working with, this question paper, it consists of section A and section B, where section A is the multiple choice and section B has got 7 questions, which we are going to see as the ones that are listed below. So we are being asked to answer all questions in these 2 sections that we have in both sections. So make sure, guys, you go through your instructions, read everything that you're given there. So I'm not going to waste your time quickly rushing into the questions that we are given. On section A, question number 1.1, we are given which one of the following is not, take note there, is not. We are given there it is not a property of what? A rational number. So you need to know the properties of rational numbers so that you'll be able to see which one of these is not. All right, let's start with A terminating decimal. A terminating decimal is the one that ends just like 0.3, 0.2, 0.5. These decimal, guys, they are rational numbers. We write them 3/10, 5/, they are rational numbers. So this one is a rational number. A recurring decimal is also a rational number. Remember, it is list of the rational numbers. So we have the rational number there. On C, the square root of a perfect square. There was another question paper that I explained more about this, where I refer to the square root and also the perfect cube of cube roots. So when you are given the square root, it must be of a perfect square for it to be a rational number. So this is a rational number, guys. We have got a perfect square there. So that's a rational number again. If we are dealing with a cube, if we are dealing with a cube, the cube root of something, we must have the cube root there. So the cube root there, we must have the cube there. That is the condition that you're working with. So a perfect square, and we also have a perfect cube. A perfect cube, which is under the cube root. You must have a perfect cube such as 27, cube root of 81, and so on. These are rational numbers. All right, let's move on to D, the cube root of a prime number. Guys, what is a prime number? Number that is divisible by 1 and itself. Remember, prime numbers, if you are listing prime numbers, 2, 3, those numbers, if we are to find the cube root of these, are they going to give us a rational number? No. Is the cube root of 2 an exact value? No. Can we determine the cube root of 2? No. Even on our calculator, if we are to use this, the cube root of a 2, look at this, an endless decimal. This is not a rational number. So the perfect answer was going to be B on that one. So you just have to go through and check the answers that you're given. Calculate. We are given this and the answers. -3 squared plus 3 squared. take note, the minus is not in a bracket like this. When it is inside a bracket, you raise the negative also to the exponent of 2 so that you get a positive. So it'll be positive 9. But in this case, the negative is on its own. So you're going to write the negative, but 3 is raised to the exponent of 2. So that's minus 9 plus 3 squared, which is 9. So guys, if we are to simplify this, that was going to give us negative 9 plus 9, which is a 0. And the answer is D. So take note, they might give us a similar question like this, minus 3 squared plus 3 squared like this. When a minus is inside a bracket like this, you square it. It is also affected. This one is not affected. So it is minus to the exponent of 2, which is going to be positive. So 3 squared, that's 9. So it's going to be 9 plus 9, which is 18. So you see the A there is a confusion that you're given there. All right. So A is not our answer. A is the answer if it was like this, if there was a bracket. All right. So the best answer was D. On 1.3, the constant difference, already we are told that we are dealing with what? A constant difference. That's a linear pattern that we are given. So we're just going to find that one. All right. Remember, term 1, this is term 2, term 3, and so on. That difference is simply the difference between T2 and T1. So that's 7 minus 4, which is 3. 10 minus 7, which is 3. 13 minus 10, as we can see, guys, that is the 3. I mean, the number that we have there is 3. So the answer was going to be D. 1.4, as a continuation, we are given the following expression equals to. All right. If we simplify this expression, what are we going to have at the end? 3x plus 6y like this over x plus 2y. So guys, let us simply factorize the numerator. As we can see, 3 is common. It is the highest common factor here. So we can factor out 3. 3x divided by 3, that is going to give us x. All right. Remember, guys, I'm saying factorize. Factorize. So if factor out 3, that was going to give us x. 6y divided by 3 is going to give us 2y. So that's 6y over 3. That is going to give us 2y like this. Everything over what? This denominator as it is. So you must get rid of the denominator. In this case, as we can see, the denominator and the numerator are exactly the same. So these two, they can cancel. You are going to remain with 3. It was just going to be 3 over 1, which is what? Which is 3. So the best answer was going to be C, where we have got what? A 3. So that is it, guys. 1.5. If we are given these two brackets, x minus 1 into the bracket of x plus 2 being equal to 0, then x is equal to what? This question is under equations. So the question is simply you are given to solve for x. How are you going to solve for x? Remember, I talked about these guys, two brackets. When they are equal to 0 like this, you are going to equate each bracket to 0. So you're going to say, let x minus 1 be equal to 0. All right? Or this bracket of x plus 2 also be equal to 0. So that's it. So what was going to be our x values? We add 1 to get rid of the minus 1, both sides. So this was going to cancel. So 0 plus 1, that's a 1. We're going to subtract 2. We subtract both sides. This was going to cancel. X is equal to 0 minus 2, which is minus 2. Where do we have 1 and minus 2? 1 or minus 2. So that is A on that part. All right. So the best answer was going to be A. So the rest is wrong. So that is how we were going to solve this equation. Section B, on question number 2, under whole numbers, we are given 2.1. Decrease 300 in this ratio of 5:3. So when you are given to decrease, you take the smaller value, which is 3. So that's 3 out of 5 times what you are to decrease. 300. If they said increase, you are going to take the bigger value, 5 out of 3 times the number that you are supposed to increase. So this one is for an increase, you take the bigger value. For a decrease, you take the smaller value. So it's smaller value to the other value. That's it. Just like that, guys, you're done. So 3 out of 5 times 300 was going to give us 108. You can even use your calculator. That's 3 over 5. 3 over 5. All right, let us just start again. All right, 3 over 5 times 300 times 300 like this. All right, we need a times there. 300 like this. So that was going to give us 180, as we can see. All right, then on question 2.2, find the HCF, the highest common factor of 36 and 68. So as we do understand, to determine the highest common factor, it is best if we have got these numbers written as a product of their prime factors. So we must have the prime factors. So let us have 36. The prime factors, guys, these are the numbers such as 2, 3, 5, 7. These are the prime numbers, exactly divisible by 1 and itself. So for 36, let us start with 2. 36 divided by 2, that is 18. We do the same thing. 18 divided by 2, that is 9. We can see that if we use 2, we're not going to get an exact value. So let us move on to 3. 3, if we use a 3, 9 divided by 3, that's a 3. Again, 3. 3 into 3, that's a 1. All right, so this is it. We move on to 68. Do the same thing. Divide, start by 2. 68 divided by 2, that's 30. Okay, it's going to be 34. 34. 2 again, 32 divide, that's 34 divided by 2, which is 17. It's going to be 1 and 17 there. All right. Then a 17 is a prime number. There is no number that you can use there. We cannot have any prime number, so it's just going to be like this. So let us see what we are having here. We can even take the answers by just looking into the factors. 2 is common. We've got a 2 and a 2 here. We also have these 2 here. We also have a 2 here. So that was going to be 2 times 2. As we can see, 3 is not common. 17 also is not common. So it was just going to be 2 times 2, which is what? Which is 4. Just like that. Or you can have your numbers written as a product of their prime factors in index form. 36, that's 2 times 2, which is 2 to the exponent of 2 times 3 times 3, which is 3 to the exponent of 2. All right. Then we move on to 68. 68, that's 2 to the power of 2, 2 to the power of 2 times 17. So remember that the highest common factor, I said it must be common. And if it is common like that, you take the one that has got the smallest power. These two, they are raised to the same power. So it is going to be 2 to the power of 2. 3 is not common. We don't have it this side. 17, we do not have it this side. So 2 to the power of 2 was going to be our highest common factor, which is what? Which is 4. Just like that. So guys, you see it is easy like that. You just have to revise as many questions as you can, do as many questions, of which guys I've managed to work out many question papers for June. So you can see from different provinces, how do they ask these questions and relate from there. All right. On question 2.3, we are given that Emily invests 12,000 Rand in a savings account at 5% per annum compound interest. Take note. Compound interest. We are dealing with a compound interest. Remember, under the compound interest, I refer to many formulas. We can use different, but we can even use this one. Amount is equal to principal into 1 plus the interest rate over 100 to the exponent of n. This is the formula for the compound interest, where A is the accumulated amount, P is the principal, the amount that is invested, the money that you invest. This is the interest rate per annum. These are the number of years. So we are given that Emily invests 12,000. The money invested, that is the principal amount that we are given there. The interest rate per annum is given as what? 5%. How much there, we calculate how much there will be in the savings account after 3 years. Calculate how much, which means the accumulated amount after that period of 3 years, time number in years is 3 years. N is the number, the time in years. So we need to calculate A. This was a direct question because you just needed to substitute as it is into the formula. The principal, we have it, that is 12,000, open bracket 1 plus the interest rate as a percentage. Since there is this over 100, you use it as a percentage as it is. So that is 5 over 100. Everything is raised to the exponent of n, the number of years, which is 3. So on this one, make sure that you use your calculator properly, guys. At this stage, you're supposed to know how to use the calculator. All right, so let us have our calculator together. 12,000, we open the bracket, that is 1 plus, there is a fraction, so you have that fraction, which is 5, right? Let's move aside. This is 5 over 100, so that's 5. Bring this down over 100 like this. And then you have to move aside this arrow like this. So when it is on the side, then close the bracket. To the exponent of 3, that's x here to the exponent. Then you put the exponent of 3. This is equal to, we have your answer. Press the SD button. It is going to give us this value 1, 3. We can even round off to 2 decimal places if you want your answer, but just put a 0 there. You can do this. Shift. You go to the setup, we fix number 6, then we press 2. So that was going to give us this value with a 0 there to 2 decimal places. So that's 1. So the amount is going to accumulate to 13,891,50. All right, so that's 1, 3. Then we've got 891 like this, 13,891,5. But we've got what? A 0. Remember, dealing with the money that is 2 digits after the comma according to our mathematics. That is what we are going to have. So these are the questions, guys, that you must expect also as you were working with the compound interest. Remember also your simple interest. Question 3, it was on integers, where we are given simplify the following without using the calculator. Yes, we can use the calculator just to verify the answers that we are given. I mean, the question that you're just to verify. You are going to calculate, yes, but just verify to say -5 like this, plus, we open a bracket, then we have got -8 plus 16 like this. All right, let me just remove that fix that I did. So I have to go to the setup, then go to number 8, normal, then number 2, so that I go to the normal version. All right, so the answer was going to be 3. So as we are going to calculate, we know that the answer is 3. Just use the calculator to verify. Anyways, how do we simplify this without using a calculator? So we are given -5 plus -8 plus 16 in a bracket like this. Remember your BODMAS or BOMDAS. So you can have BODMAS or BOMDAS. Are we having brackets first? Yes, we have got the brackets. So we must simplify what is inside of the brackets first. All right, so let us get this. This was going to give us Negative 5, we just take as it is, plus, we simplify this part inside the brackets. Minus 8 plus 16. It is the same as 16 minus 8, which is what? Which is going to give us 8 inside the brackets. At this stage, we can just combine addition, subtraction, guys. It's just the same. Minus 5 plus 8 is the same as 8 minus 5, which is going to give us what? 3. As we can see, the same answer that we had before. So this is what I'm trying to say. You can just use your calculator to verify. Do not write a wrong answer while the calculator is there. Use the calculator to see, is this answer correct or not? 3.2, again, let us also just verify our answer before. That's minus 10 times 2. Then we have got plus, we're going to have a fraction, minus 10 over minus 2 like this. As it is, make sure that your calculator displays as it is there. So this is going to give you minus 15. So you know that if you are to simplify this, your answer is what? Is minus 15. But let's see. All right, so that's 3.2. We have got minus 10 times 2 plus minus 10 over minus 2. Remember your BODMAS. Like I said, some, they even use BOMDAS, one and the same. Meaning to say, where a multiplication is or where a division is on these two, we have to work it at the same time. It does not matter which one are you working with. So here there is a multiplication. Here, these two, they're under a multiplication. So I can combine this. At the same time, I'm going to combine these two because they're under a division. So what are we going to have? That is negative 10 times 2, which is negative 20. Plus, as you can see here, there's a plus. Then we combine these at the same time because they're under a division, multiplication and division. Do it at the same time. So negative 10 divided by negative 2, that was going to give us 5. This one was going to cancel. All right, so we are left with minus 20 plus 5, which is what? Minus 15. So as we can see, guys, same answer as what we had before. Let us simplify another part, which is 3.3. On 3.3, we are back to the exponents. We have to apply the exponents there. Even the calculator cannot help. So we have got the cube root of x to the exponent of 18 over x squared, then raised to the exponent of 2 like this. So let us bring back our exponents, guys. What made us to have the cube root of this? Remember, if you have got x to the exponent of m over n, it gives us the nth root of x to the exponent of m, the nth root. It simply means, or it simply tells us that from this side, we can go back like this. Take note. It is the exponent divided by what is inside of the root sign. M over n. The exponent divided to this, what is inside. So that's x to the exponent of 18 over 3. We have removed this part. We have just rewritten it like this in a way that we understand much better. All right. What about this one? Which law are we going to use? Remember that if I have an exponent and another exponent, I can simply combine these to a times b. So it will be x to the exponent of ab. So these two can multiply each other. That's x to the exponent of 4. All right. So let us move on and see what were we going to have. 18 divided by 3, or 3 into 18 is going to give us what? 6. So that's x to the exponent of 6 over x to the exponent of 4. Division of the same bases, the base of x, the base of x. What are we going to do? We subtract the exponents. Remember, x to the exponent of m over x to the exponent of n is going to give us x to the exponent of m minus n. We subtract the exponents. So this is what you are simply going to do at the end. That was going to give us x to the exponent of 6 minus this other exponent, which is 4. So 6 minus 4, that's 2. You're done. So that is it, guys. On this one, that is how we're supposed to simplify. All right, up to the last stage. That's 3.3. Then now we move on to 3.4. Simplify again. So let's see what are we going to apply on this one. Again, some parts of our exponents are to be used there. We are given minus 6a to the exponent of 3 times minus 6, all right? So this is 6 b to the exponent of 3, like this. Everything over, right? Let's see what we're given there. That's 12a to the exponent of 3, b to the exponent of 3. All right, so let us try to analyze for 3 marks. All right, let's see. If we are to consider properly here, we can see that there is a bracket which is true. But what is affecting this bracket? It's nothing. There's nothing. It's just like there's a 1 here. So this is just the same as, guys, this one times this one. The bracket there's no effect. There's no other exponent that we have there. So it is just like we've got minus 6a cubed times minus 6b cubed. So negative times negative is going to give us a positive. 6 times 6, that was going to be 36. Then we combine these two, a cubed, b cubed. So that's it. So this was going to give us 36, a cubed, b cubed. Everything over what? The denominator as it is. 12, a cubed, b cubed. As we can see, these two are simply the same. They can cancel. This one can cancel. So what is 12 divided by 4? 36 divided by 12, or 12 into 36. That was going to give us what? A 3. So as we can see, guys, we've got a direct value just like that. So these are the typical questions that you can have. On question number 4, which is an exponent, simplify the following using laws of exponents and leave your answers in exponential form. All right. 4.1, 18x to the exponent of 0. We know that a number, when it is raised to the exponent of 0, that's a 1. So this one is simply 18 times a 1, which is what? Which is 18. So we are given now to say the answer is supposed to be in exponential form. How can we write 18 in exponential form? We can have 18 this way. Product of its prime factors 2 into 89, then 3, 3, 3, 1. So 18 is same as 2 times 3 squared in exponential form, if you want to have it that way. So that is what we were going to have. 4.2. Okay, let's see what we have there on 4.2. 6 to the exponent of 2 times 6 divided by 6 squared. All right, so there is a multiplication. Remember, if you're multiplying same bases, you add the exponents. So this is 1. So we are going to add the exponents. So that's 6 to the exponent of 2 plus 1, which is a 3, divided by 6 to the exponent of 2. Division, same bases, you are going to subtract the exponent. So that's 3 minus 2, which is going to give us 6 to the exponent of what? Of 1, which is the same as what? As 6. So this is just same as what? As 6. So 6, you can just have it like that one, guys. These ones, do not worry, guys. Just leave your answers like that. Then 4.3, the exponents are most important for the terms, like if you're given these x and so on and so on. But for these numbers, just leave your answer as 6 as it is. All right, moving on to 4.3, we are given that's x to the exponent of minus 2, y to the exponent of 2, everything to the exponent of 4, times 12x squared. Remember, I talked about this where there's an exponent, it is going to affect each and every term inside. So the x is going to be affected. So this 4 is going to multiply the minus 2 on x. So that's x to the exponent of minus 2 times 4, which is minus 8. The part of y also, 2 is going to be affected by that 4. So that's 2 times 4, which is 8. Everything that we have here times 12x to the exponent of 2. All right, let's try to simplify this. This here is just same as if we have got a 1 here. So we're going to multiply 1 times 12. So this was going to give us 12. As we are multiplying this part of x and x, remember these are same bases. So if we are multiplying, we add the exponents. It was going to be minus 8 plus 2, which is what? X to the exponent of minus 6. The part of y is not affected. We do not have the y this side. So it is going to remain as it is. So that is what we're going to have. We can even get rid of the negative exponent. Remember, x to the exponent of negative n is same as 1 over x to the exponent of n. So this one, we can get rid of that. So it can be written as 12 y to the exponent of 8 over this one, because it is having a negative, it will be written in the denominator, x to the exponent of what? Of 6. So you can have it this way, you can leave it like that. It is still okay. 4.4 we are given laws of exponents again. Remember your laws of exponents. So if we are to consider 5x to the exponent of 4, if you are someone, you can even cancel, because this one and this one are the same. You can even cancel that if you want. Then you just simplify the remaining part, or you can simplify the numerator on its own. 5x to the exponent of 4. Remember this condition, 2 is raised to the exponent of 3. So that is going to give us what? That is going to give us 8. X is also raised to the exponent of 3. Everything over what? The denominator, 20x to the exponent of 4. So let us combine the numerators together. The numbers, 5 times 8, that was going to give us a 40. So that's 40. Remember, the bases here are the same. So when I multiply, I'm going to add the exponents. 4 plus what? Plus 3. So that was going to give us x to the exponent of 7. Everything over the denominator as it is, 20x to the exponent of 3. So with this condition, we can divide the numbers on their own. 40 divided by 20. So as we can see, guys, this is going to give us a 2. So that's 2. These ones, they can be divided on their own. Remember, same basis. Division, we are going to subtract. So it's going to be 7 minus 3. 7 minus 3, which is what? Which is 4. So that's 2x to the exponent of what? Of a 4. So that is how these questions, right here, guys. How did I change a 3 to a 4 here? This one. Let's go back here. This is a 4. This is a 4 that we are having here. So meaning to say, if we are to correct this one, it's going to be 7 minus 4. All right, so that's x to the exponent of 7 minus 4, which is x to the exponent of what? Of 3. So this is what we were going to have at the end. So let us correct that part, and we try by all means use the laws of exponents properly each and every time. Question 4.5. How can we simplify this part? Again, here is a part, a lot of terms actually. So let us try to use the BODMAS as well to just try separate. We do not, all right, the brackets, they're there. There's a bracket here. So let's get rid of that one. So it was going to be 3x to the exponent of 3 times 2x to the exponent of 3 plus 6x to the exponent of 2. We simplify this part of a bracket. Remember, a negative raised to the exponent of an even number. 2 is an even number. It is going to be positive. Then we have got x squared raised to the exponent of 2 like this. X squared like this. So you multiply. So that was going to be 4. So remember this one, it's a product. So that's times x to the exponent of what? A 4. So if we are to see properly here, these two terms are under a product. These two terms are under a product. So we can use our laws there. Under a product, so let us multiply 3 times 2, that's 6. We are multiplying same basis here. We add the exponents 3 and what? And 2. 3 and 3, sorry. 3 plus 3, which is 6. Okay. Plus, we do the same thing here. There is a 1 here. So that's 6 times 1, which is 6. The x and the x are the same. So you add exponents, remember? Multiplication. So that was going to be 2 plus 4, which is 6. So there we are. Can we use the laws of exponents here? No. At this stage, we have what we call like terms. The exponent of 6, this one, x to the exponent of 6, x to the exponent of 6 are the same. So we can easily add their corresponding coefficients, the 6 and the 6, just like that. So we add these two, 6 plus 6, which is going to give us 12. Remember, these two, they remain as they are. There is no law that is being used. We are just adding. It is just like you're adding 3x plus 2x. These are like terms. You just add the coefficients 3 plus 2, which is 5, and your answer is having what? X. So this is the same consideration. The x to the exponent of 6 is not going to change on that addition. So that is how our solution was going to look like, or answer. All right, question number 5, numeric and geometric patterns. On this one, consider the following sequence: 7, 10, 13, 16. Write down the next two terms. If we are to consider 10 minus 7, there's a difference of 3. Here also a difference of 3. 16 minus 13, a difference of 3. So guys, we are simply adding 3 from one term to another. We add 3, 7 plus 3, that's a 10. 10 plus 3, that's 13. 13 plus 3, that's 16. So 16 plus 3 is what? It's 19. 19 plus 3 is going to give us what? 22. So these are the two terms that we want, 19 and 22. Study the pattern and see. Then 5.2, determine the general rule, which is the nth term. As we saw that there is a constant difference. Wherever there is a constant difference, guys, remember your formula. Remember your formulas, guys. Our Tn is equal to what? Tn is equal to the constant difference times n plus what must be added to give us what corresponds to that term. So if I use the first term here, which is 7, T1 is equal to what? To 7. T1 is equal to 7. So I'm going to have 7 is equal to, in place of n, there is a 1. So I'm going to put a 1 where there is n. So that's 3 times 1 plus what must be added. So 7 is equal to 3 times 1, which is 3, plus that part which must be added. Let us take the 3 to the other side, or subtract 3 both sides. 7 minus 3, that's a 4, which is equal to that part which must be added. So the number that we need here is what? A 4. So therefore, guys, our Tn was going to be written as 3n plus what? Plus 4. So that is 3n plus 4, like this. This is it. Just like that, guys, you are done. All right. Calculate the 28th term, the 20th term. N is equal to 28. So substitute in place of n. So T, 28, is equal to what? In place of n, 3 into 28 plus a 4. So there we can even use our calculator at once, we can simplify this. You are going to get 88, all right? 5.4, which term find n of the sequence which is equal to 304 when Tn is what? 304. What is n? Which term? So we're given the Tn, guys. Remember, our Tn is here. So it's just going to be a continuation from this Tn. Tn before is given as this one. The same Tn is 304. The same, the Tn, they are equal. So we can equate to say this 3n plus 4 that we see is also equal to the value of Tn, which is 304. We have formed an equation. Let us solve for what? For n. Let us solve for n. So we're going to subtract 4 here to get rid of this 4. So that's 3n is equal to 304 minus 4. That was going to give us what? 300. Divide by 3 both sides. So our n was going to be 100. We'll just use your calculator. So this one was a little bit direct. On question number 6, 6.1, given this whole expression, 6.11, how many terms does the expression have? How many terms? We count them. This is 1, that is 2, that is 3, that is 4. So we have got 4 terms. 4 terms. 6.12, what is the constant term where we do not have the variable x, the variable a, the variable b, the variable m as we have it here? Where are we not having that? It is on this minus 6. So our constant is -6, where we do not have the variable. Then lastly, determine the value of the expression if m is equal to 1. They are simply saying, in place of m, put a 1. Where we see m, put a 1. So this was going to be 10 into what? 1 to the exponent of 4. Minus 2 into m, our m is 1, so that's 1 to the exponent of 3. Plus 8 into m, which is our m is 1, minus 6. We substitute, then we can simplify. So there you can even use your calculator, it's fine. But guys, any number, 1, when raised to any number is going to be 1. 1 to the exponent of n is 1. So 1 times 10, that's 10. 1 times 2 minus 2. 1 times 8, that's 8. Minus 6, then combine here. 10 minus 2 is going to be 8. 8 plus 8, that is 16. Then 16 minus 6, that is going to give us a 10. All right, so I just hope you are also getting the same answer. Like I said, you can also use your calculator direct. 6.2, under these algebraic expressions, we are being asked to add these two. So addition, guys, is in your hands. You can even write x squared plus 2x plus 7, then plus add means you're going to put a plus. So that's plus. We take this one as it is. X squared minus 5x plus a 3. All right, let's add, guys, the part of x squared on its own. So there is a 1 here. So if we add 1 plus 1, that's 2x squared. The part of x on its own. So this is 2 plus minus 5. 2 plus minus 5. It simply means 2 minus 5, which is what? Minus 3. So that was going to be minus 3 with what? With x. 7 plus 3. 7 plus 3 is what? Is 10. So this is what you're going to have at the end. All right. 6.3. Expand and simplify. All right. So this is what we are given here. To expand and simplify. These are bracket, there are two brackets, 3 into 2x plus 3, another bracket, 5x minus 5. So remember, when you're given something like this, you can work with these two brackets, it's fine, or you can use the 3 in one of these brackets. Then you expand the rest. So for us not to have confusion, guys, I'm going to leave that 3 on its own, this 3. Then expand these two brackets as we do understand our FOIL method. So meaning to say, if we expand, the first bracket is going to expand the second one. So 2x multiplies everything in the second bracket. The plus 3 multiplies everything in the second bracket as well. All right, so let us multiply 2x times 5x. That is going to be 10x squared. We do the same thing, 2x to this minus 5. So that's 2 and minus 5 is going to be minus 10x. All right, we are done with the first term, 2x. We move on to the positive 3. So that's positive 3 times this 5, x, which is going to be 15x. Positive 3 and the negative 5, which is what? Negative 15. Before you expand by this 3, you can even simplify inside the brackets because we've got like terms there. The negative 10x and the positive 15x, these are like terms. We have x there. Only x raised to the exponent of what? Of 1. So minus 10 plus 15, that is a positive 5. So that's 5x minus 15 like this. Then we can expand by the 3, which is outside. So 3 multiplies everything. We have to distribute by the 3. So 3 times 10, that is 30. So it's going to be 30x squared. 3 times 5 here, that is 15. So it's going to be 15x. 3 and minus 15 at the end here is going to give us minus 45. So this is what you are going to have at the end. All right, again, on our algebraic expressions, this time they want us to factorize these expressions fully. All right, on question 6.4, factorize fully. 6.41, we are given, that is 2 terms there. So when you're given 2 terms, guys, just look for the highest common factor. 6 and 12, sorry, that is 6. Between y and y, we're just going to take the y as it is. As you can see, it is raised to the same power. So that is our highest common factor. So let's factor out this and see. 6xy divided by 6y like this over 6y. As you can see, this was going to cancel and this one cancels. We remain with what? With x plus 12y divided by 6y is going to be 2 there. Because the y and the y was going to cancel. 12 divided by 6, that's a 2. So this is it, guys. As you can see, this is in simplest form. There is nothing common in this bracket that we can further factor out. There's nothing. All right. Let us check a trinomial that we have on 6.42. That is a quadratic expression. Trinomial, we understand when we are given something of this nature, x squared minus 3x minus 18. I think now, guys, we are used to this. I said focus on the coefficient of x squared. It is 1. So we're going to have x here, another x here. Then you ask yourself, what are the products, the two factors that I multiply and obtain minus 18? But when I add these factors, I'm going to get a negative 3. There are only 2 numbers there. Negative 18, there are so many numbers that we can multiply to get a negative 18. Negative 18 and 1, 18 and negative 1, negative 6 and 3, 6 and negative 3, 9 and negative 2, negative 9 and 2. There are so many. But out of these, there is one part when we add, we are going to get a negative 3. And this part is between -6 and +3. So meaning to say we are going to take these as they are. -6 here, +3 as it is. So it's a trial and error. You try all the factors, try add. Where are you going to get a -6? From these products of -18. You must start from the products. Then you ask yourself this, where am I going to have the sum, which is going to give us what is on the middle term, which is the -3. All right, checking on number 7, algebraic equations. Let us consider 7.1. Solve the following equations. 7.11, x minus 2 is equal to 16. Guys, simply add 2 both sides to get rid of that -2. So x is equal to 16 plus 2, that's 18. All right. There we have got 2 brackets. Remember, I told you 2 brackets equal to 0. One of these brackets, x minus 8, must be equal to 0, or the other one, x plus 6, must be equal to 0. So our x is going to be what? So there are 2 possible values of x. On this one, there's a -8, so add 8 both sides to get rid of that 8. 0 plus 8, that's 8. There is a +6, so subtract 6 both sides. So that's 0 minus 6, which is what? -6. So these are the 2 answers, just like that. 7.2, if we are given that y is equal to x squared minus 4x, calculate the value of y if x is -2. So they are simply saying in place of x, put -6. If x is -6, I mean -6 to the power of 2, as it is. -4 into x, which is our x is what? -6. Then simplify. What are you going to get? -6 raised to the exponent of 2 is going to give us a +36. Remember, a negative is inside the bracket also. So that's +36. Negative times negative, that's a +4 times 6, which is 24. So adding these 2, we were going to get a +60. Just like that. You're done. So guys, you see these questions, they're just direct sometimes. On question 7.3, we are given 4 times a certain number. A certain number, we do not know it. So let that number be x. So that's 4 times x. Increased by 6. To increase, add 6 to that. Is equals to 26. It is equal to 26. That is what this is the statement that we are given. 4 times a number. We increase it by 6, we must get 26. From this statement, the question is find the number, find x, solve for x. Solve for the unknown depending with what you have according to equation. So that's it. Just like that, guys. So let's get rid of the +6. Get rid of that one. Subtract 6 both sides. That was going to give us 4x is equal to 26 minus 6, which is 20. That's a product. So divide by 4 to get rid of the x. Remember your product, guys. So that is divide by 4 here, divide by 4 here. We are going to remain with x. So our x was going to be 20 divided by 4, which is what? Which is 5. Just like that. So this is how these questions might be given as. On question number 8, match the representation of the function in column 1 with the representation of the same function in column 2. This is column 1, column 2. All right, let's start with 8.11. Subtract 1 from the input. Remember, input is x. And then multiply by 4. So they are saying subtract 1 from the input, that's x minus 4. If we do this, if we subtract 1 from the input, whatever that we are going to have, we must multiply it by what? By 4. So we can have the whole bracket like this times 4, or we can have the 4 here. So this is the indication, which can be also written as, since this is the input of x minus 1, we can have it this one that we are given here. It's exactly on C. If you take the number, which is 2, this one, our input, let's just try and see. We put a 2 here. 2 minus 1, that's what? That's a 1. Times the 4, which is outside. 1 times 4, that's a 4. Exactly what we have on the output. Do this for any number that you want. You are going to see that this is exactly the rule that we are talking about, which is written or presented on what? On C. So 8.11, the answer was going to be C. 8.12, from this table that we are given, which one gives us exactly what is meshed on this table? Is it these two? Because these are the remaining answers. On this one, we can even test, guys. Test your values there. There are only 2 answers. Y is equal to x squared. Put a value there and see if it is going to give you answer, minus 2x squared. Y is equal to 2x squared. Our x is what? Minus 2. Let's put there and see if we are going to get 8. In place of x, y is equal to 2 into minus 2 to the exponent of 2. Y is equal to 2 into minus 2 squared. That is going to give us a 4. Then 2 times 4, which is 8. As we can see, we are getting exactly the 8. We can do this on this one and see. We put a minus 2 here. 2 times minus 2, that's minus 4 plus 8, which is going to give us a 4. As we can see, it is not giving us this 8 that we are seeing. This is totally wrong. So the answer was going to be A. So 8.12, the proper answer there is A. Then definitely 8.13, it is going to correspond to B. But we can even try and see if B is the answer, because that is the only remaining answer that we have. Y is equal to 2x plus 8. Test, guys. When x is 0 there on your input, the output must be 8. So let's put 0 there and see. Y is equal to 2 times 0, that's 0 plus 8. As we can see, y is equal to 8. Okay, let's move on to another one. We can try a half. This one, 1 over 2. Y is equal to, in place of x, we put 1 over 2. So it's 2 times 1 over 2 like this, plus 8. 2 times 1 over 2, that's 1. 1 plus 8, that is 9. Exactly the 9 that we see there. So this is exactly the answer that we want, this one. Y is equal to 2x plus 8. It corresponds exactly to 8.13. So B corresponds to 8.13. That is it. Just like that. So 8.2 we are given. If the rule for finding the output value, which is y in this case, is given by this, determine A and B. So guys, there we are already given the rule. Just to substitute, we are already told y is equal to minus x plus 6. So to find this A, we are given x value, the input, which is x. So in place of x here, put a minus 3. So that's minus 9 into minus 3 plus a 6. Minus 9 times minus 3, that's a positive 27 plus 6. 27 plus 6, that is 33. So as you can see, our A is 33. To find B, B represents the x value. This is the input, where we are given minus 48, which represents the y value. So we are given the y value minus 48 is equal to, we take the rest of the equation as it is, minus 9x plus 6. So we must solve for x because b represents x. So let us solve for x. How are we going to solve? Get rid of the 6. Subtract 6 both sides. So that is going to be minus 9x is equal to minus 48 minus 6, which is what? Minus 54. You can use our calculator there. This is a product, so simply get rid of the negative 9 by dividing both sides. So minus 54 divided by negative 9 was going to give us a positive 6. So x is positive 6. X representing what? The b value there. So this b is what? Positive 6, just like that. So these are the typical questions, guys, that we can have. Let us just try to revise as many questions working with our question papers. The introductions, as I have worked them, try to figure out each topic. Where you do not understand, the comment section is there. Let us communicate. And for those who are ready for the preparations for term 3, the ATP is already there for term 3 for last year. Use that one. It is the same ATP that we are going to have for this term 3. So you can also go through the videos for term 3. If you've got challenges, the comment section, guys, let us utilize it in the revisions that we are going to have. So that is it, guys, for Maison African Motives. Till we meet again.